Okay, so on this video what I'm going to do is go over the logic notes worksheet. I won't be doing every exercise, but I will be doing most of these. This is going to be quite a long video, all right? So let's get you started. So the first thing is you've got these two, on number one you've got these two gates. So we should know from the previous video that that's an OR gate, that's a NOT gate. Now an OR followed by a NOT, so there's an OR gate followed by a NOT gate, is the same as, now this is where my drawing is pretty bad, it's the same, so they're the same, okay? So equivalent, right? Now, so the first thing is we want to do the truth table for that. Now, the truth tables for these things are pretty straightforward. Now, you've got A and B as the inputs, so you've already got those in for you, so you don't need to worry about that. Now what we want to do is fill out the Q column there. But in order to do that, to make it easier, we have C here. Now C is what we call an intermediate. Okay, now you can add those in to make life easy for you. Okay, so that's an intermediate point. It's not actually the answer, but it helps us get the answer. So we have an OR gate. So if you imagine, then we've got the inputs flowing through A and B. So A and B, to get to C, what's happened to them? Well, what's happened is they've both gone through an OR gate. So if you imagine then, so what we're going to write at C is basically the ORing of A and B. All right. So the ORing of A and B, as we all know, or we should know, is that. Okay. Then from C it travels through the NOT gate. So knotting C, we're not looking at A and B anymore. We're just looking from C here, going through C, and knotting it. So that becomes 1, 0, 0, 0. Right. So there we go. There's the answer for the first one. Now let's do the second one. Same sort of thing again. We have two intermediates this time. We have C and D. All right. So what happens at C? Well, A flows through a NOT gate, so we're going to inverse A. So it becomes 1, 1, 0, 0. So I'm just looking at A, this column here. Okay, and then I'm saying I'm inverting it to become C. All right. Now I look at B. So what happens? Well, it flows through the inverter or the NOT gate again to become D. So D is the inverse or NOT of B. So I'm just going to invert that. So it becomes 1, 0, 1, 0. Right. So we then have an AND gate. Okay. What's the inputs for our AND gate? Well, I'll just follow it back. It's C and it's D. So that is the ANDing of C and D. Okay, so that's a 1, 0, 0, 0. So there's our truth table for that one done. Okay. Now, what you could be asked to do is to produce a Boolean expression for a circuit. So now the Boolean expressions are always in terms of A and B. All right, always. So your intermediates won't actually be part of that Boolean expression, but you can still count. So you're going to say, well, okay, well, what is the Boolean expression at C? Well, A and B are being ORed. All right, so A or B. So that's what it is at that point. Now, what I always imagine is that if you imagine A or B here, I might be able to go on. Let's try that. Right. So what I could do then, I imagine that was moving through there. So that A or B travels through that NOT gate here and becomes knotted. So we put our, oh come on, a line above the whole thing. All right, so it goes above the whole thing. So originally there we had at C we had A or B. It travels through the NOT gate, so the whole thing becomes knotted. So the Boolean expression for this circuit is is that. Okay. Now I'd like you to have a go at doing the Boolean expression for number 2. I'm going to do that, so just pause the video for now and try it. Right. Okay then. So what about the Boolean expression for number 2? Right. So what do we have then? We have okay. Cool. Right. So at C we have what's happening to A. A goes through a NOT gate, so we have NOT A. We have B. B travels through D, become NOT B. And then both of those, if you like, travel through an AND gate. So we have NOT A and NOT B. Okay. So that is the Boolean expression for, I don't know, I'm trying to use the pen here, it doesn't work on that. There, the Boolean expression for that circuit. All right. Now you'll notice, or you may have noticed, that the actual, as I said, this is the Boolean expression for this truth table, or circuit if you like, is that, and that's the Boolean expression for this one. Now you notice it's the same. The actual outputs are the same there. So what we can deduce then, that these two, A, not A and not B, is the same as A, don't forget the not there, A nor B. They're the same. And that's, which we'll come back to later, is something called De Morgan's law. Okay, right. Okay, now that's the first one. So that's basically how you do these. They're fairly straightforward. Okay. Number 3 is create a truth table and a Boolean expression for the following circuit, which is this circuit here. Again, we've got an intermediate here at C, so we're going to fill out C and put the answers in there. Okay, I'm not going to go through that one. Now this one here is slightly different. So it says create a circuit and a truth table for the following Boolean expression. Now I'll give you some help with this one to get you started. Now, so what do we have here? We have A and B. We only have 2 inputs, so we just put A and B. Okay. Now we've got these in brackets, so we've got a that's an AND there. So that's an AND, another AND, that's an OR, and that's a NOT gate. So we get the idea. That's what we're going to be doing. Now this and that are in brackets. It has to be done before the OR. Okay, so we're going to have 2 AND gates, an OR gate, and we're going to have a NOT gate. So let's put that in there. Right, so I won't do any more than that. Now, well, I will do a little bit more. Okay, so if you like, then because there's no need, you don't do A and B again. You just draw it over like that and like that. Okay, so now this is where I go crazy with the color highlighting. Let me just not have this full screen. Right, so that there is that. Okay, this one here is that one, and then that's going to be that one. Okay, right, so that's number 4 done. Now so that's going to create a truth table and a Boolean expression. Now the truth table, I put intermediates on there for you to do. I will just point out where I think they should go. So C is going to go there. D would go there. E would go there. Okay, so that's what it is. But basically, I'm interested in the answer at Q. Okay, so give that one a go. Pause the video and then try that. Now, obviously, in lesson, I'll be going over these answers here. Right, next one then we've got number 5. Create a truth table for the circuit below, and this one has 3 inputs. Now notice that means you've got 3 different values, so you can have way more combinations. Now because we have 3 inputs, 2 to the power 3 equals 8, so that's 2 times 2 times 2, 2 2 is 4, 2 4 is 8. So you've got to basically count in binary now. 0, 1, 2, 3, 4, 5, 6, 7. So that last one's going to be 7 there, or 1, 1, 1, and this one here is going to be 0, 0, 0. Now please count in binary there. So that one there is going to be 1, 0, 0. Okay. Right. So that's your number 5. And number 6 is another one with 3 inputs, so that one should be fairly okay. Again, I put the intermediates on that one though, so it's fairly straightforward. Number 7 only has 2 inputs, so now let's create the truth table, but what I've left out there, which I should have done, is plus a Boolean expression as well. Okay, so make sure you do the Boolean expression for number 7 as well. Okay, so there we go. So that's the first one. Now, just a couple of things. De Morgan's law was mentioned there. Now, De Morgan's law is basically this: break the line, change the sign. Now, if you look at this one here, we have A and B, A and B. So what you can do then is, if you break the line, so we've broken the line here and changed the sign, so those two are the same. Okay, we can do the same again for NORs as well. So we want to break the line, change the sign, but that becomes that. So we're breaking the line there, breaking the line there. Okay, now you can the other way of doing it is that if you want to get from there to there, it's not as snappy, if you like, but basically you knot both terms, not everything, and you change the sign. But if you look at this one from going in, well, let's not go in that direction, but go in this direction, it does make sense, because if you break the line and change the sign here, you break the line, so you end up with not, that becomes a not. Okay, so 2 knots are the same length, they both have to be applicable in terms of length, they cancel each other out, which is that becomes A and B. Okay, the Boolean laws for ands and ors. Now, when I wrote this, it did make sense, but let's go through this anyway. Now, what we're saying here is A and 0 is equal to a 0. Okay. Now, what does that mean? Now, so look at that. Now, what we're saying here is, and now I'm going to just draw the AND truth table. So 0, 0, 0, 1, 1, 0, 1, 1. Now, so there's A, there's B, there's Q. Now, A and 0 is 0. Now, if you imagine here is A, there is A, and A could either be a 1 or a 0 or a 0 going up there. Okay? Now, but we're ANDing it with 0, so we're looking at this here and this one here. Okay. Now, if a is 1 and we AND it with 0, we get 0 as our answer. If a is 0 and we AND it with 0, we still get 0. So that is why that is true, whatever the situation. Okay. Now the next one, a and 1. Now it says here a and 1 is equal to a. Now, so this time there's our a column there, and we're ANDing it with a 1. So we're looking at that one and that one. Okay. So there's our 1 on the right hand side. So if a is 0 here, we get 0, which is the same as a. If a is 1, we AND it with a 1, we get 1, which is the same as a. So a and 1 is a. So basically, if you AND something with a 1, you get whatever the thing is you're ANDing it with. Okay? Right. Let's have a go at this one. So this one here, a and not a equals 0. Now this is a situation where if a is 1, then not a must be 0. If a is 0, not a must be 1. So basically the inputs are different. So we're looking at this situation here and here. Okay. In that situation, we always get a 0, and that's where we're getting that from. Now, the last one is a and a equals a. Now this is a situation where we have, they're both the same. So it's that row there, that row there. All right, both a and b, if you like. Well, if a is 0, then the other thing we're ANDing it with, even though we're not calling it b in this case. Okay, so we get the same. So if a is 0, we're ANDing it with 0, we get 0, which is the same as a. If a is 1, we AND it with 1, we get 1, which is the same as a. Now we're doing the OR for the truth table for the OR. So it's again same sort of thing. So again, I like to do a truth table for that. So it's ABQ, so it's 0, 0, 0, 1, 1, 0, 1, 1. And the truth table there is that. And I like to use the highlighter. Right, so the first one then, a or 0 is equal to a. So that's that row and that row there. So if a is 0, we get, we OR it with 0, we get 0, which is the same as a. If a is 1, we get 1, which is the same as a. All right, so that's where that comes from. The next one. Now you could just memorize these, but I kind of find if you can actually understand it, where it comes from, it requires less memorization even to do that. Right, so what are we doing now? Blue? Yeah. Right, this one, a or 1. So if a is 0, we're ANDing it with 1, we get 1. If a is 1, we AND it with 1, we still get 1. So that's basically, or anything with a 1, you're going to get a 1 in the output, and that's where that comes from. Okay, next one then, we have right, a and not a, so a or not a. So this is again the situation where our inputs are different, so it's those two lines there, and you notice we're going to get a 1 regardless, so that's fine. And then last one, running out of colours, so just as well as any 4, a or a is equal to a, so again it's those last two there. And what do we get? Well, if a is 0, we OR it with 0, we get 0. Right? Now you might think, so what? This will help in what we're going to be doing in Boolean algebra, which is in the next video, if you like. Well, it will be the next video, it's not if you like. Right, okay, there you go. You need to make sure that you've finished off those exercises from earlier on and bring those into the lesson.